Yeah, thanks. Can you hear me? Okay. Thanks for the introduction. Mark did a good job in pronouncing my name. I didn't think he could do it, but he did. Yes, I'm going to talk about clean architecture today. Some words about me. I'm a software engineer at Adesso in Germany. We're a software consultancy, so I've been in the consulting business for the last 12 years, doing Java mainly, doing a little bit of open source. And I just took this screenshot this morning to have it up to date. I just looked here. There's something wrong here in April. I think GitHub had an error or something like that. Actually, if I think about it, that's the time my current project started into the hot phase of rollout, and well, didn't have time for open source then. Okay, so that's enough about me. I'm going to talk about clean architecture, architecture in general, going to motivate what clean architecture is about, and hexagonal architecture as an instance of clean architecture. But first, I'm going to talk about the layered architecture style we're also fond of. Who has done layered architecture in a project? Hands up. Yeah, that's pretty much everyone, I guess, that much. Obviously, I'm showing this slide only to set up layered architecture to compare it to another architecture style that it's much better. So have your Rotten Tomatoes handy and throw them at me when I'm going to bash on layered architecture. But first of all, before we talk about the pros and cons of different architecture styles, let's talk about what architecture actually is. So why do we actually bother with architecture at all? Why aren't we just coding away and put it into production and it'll work? Well, it works on my machine, so it should work there. What is architecture about? What are the goals of architecture? Anyone? Why are we thinking about architecture? Just throw it at me. What was that? Readability. Okay. Usability. Well, actually, any ility you can find, right? So, yeah, you're completely right. Some people think that architecture is about making it work, making the software work. Obviously, we're thinking about when we're doing architecture, it shouldn't be in the way of making the software we're building work. So our architecture should enable the software to actually implement the requirements that were given to us. But there is software out there that has an awful architecture, but it's still working. One good example is our own ERP system at Adesso. We bought it. We didn't build it ourselves, so nothing. We didn't do anything wrong except to buy it. But it has an awful architecture. When you use it as a software engineer to track your time and track invoices and stuff like that, you just feel that it's a bad architecture underneath. You have the same forms on every page, and you have a very bad UX experience. But it's working. We're profitable. We are creating invoices through that system. The invoices are getting paid even, and it works. But it only works because we have to use it. So there is software out there that has a bad architecture, and it's working nonetheless. So this is not the main goal of architecture. You were right with all the illities. This is the quality attributes, the quality requirements to our architecture. That's what architecture is about. It's about facilitating the whole development experience, facilitating development, facilitating deployment to production or even to test environments. It's about facilitating maintenance, because maintenance is more expensive than actually building the software initially. And with these ilities we're trying to achieve with architecture, we're trying to keep the software soft. So these three phrases down here are quotes from Robert Martin's book, Clean Architecture. So we want to keep the software soft because software, the meaning of software is that it's flexible, that we can push it, we can poke at it, and it changes. Compared to hardware, for which you actually have to break things and reassemble them. We want to keep frameworks at arm's length, so we don't want to build upon the features of a framework. We don't want to bind to the framework too much, because if the framework changes, we have to change our business code too, and we want to avoid that. And we want to keep options open. We want to make decisions at the latest possible moment, and keep our options open until then. So the goal, the ultimate goal of software architecture is to minimize the lifetime cost of the software. And lifetime cost means the development cost, of course, but it also means the maintenance cost afterwards. Because that's, I don't know the numbers, but maintenance is a factor of, I don't know how much more expensive than actually building it. So, now we know that the goal of software architecture is to minimize cost, to keep options open and everything. I introduced the layer architecture in the start. So what's wrong with layers? First of all, before I start bashing the layered architecture and get thrown at with rotten tomatoes, a little disclaimer, layers are a solid architecture pattern. There's a reason why we all do it, and if you do it right, then it's a perfect decision to do a layered architecture. I'm doing it myself in my current project. In my experience, a layered architecture without more restrictions than just the layer 1 can call layer 2, layer 2 can call layer 3. This is the only restriction in a layered architecture. If you don't put any more restrictions on it, it's very prone to design flaws that creep in over time. So keep this disclaimer in mind while I'm bashing on layered architecture. So a good layered architecture is a good architecture. But one thing I have observed in a lot of projects in my career is that we're doing actually database-driven design a lot in our layered architecture. What does that mean? It means that we have a service layer in red, or a business domain layer, which is in red in these slides, and we have a persistence layer, which is blue. And in the domain layer, we have our services, stateless services that do something, that implement business logic, that implement domain logic. And in our persistence layer, we usually have an entity class, which is, for example, a JPA entity, a repository, which is the Spring Data JPA repository, perhaps. And this couples the domain logic in our services very much to the database. Why is that? It's because the entity has all the JPA annotations and stuff like that. And in our service, if we're using the JPA entity directly, we have to take care of things like lazy loading and everything that can go wrong with using JPA. I like JPA very much. I use it. I like to use it very much. But in my experience, we're actually solving problems in our domain layer that should be solved in the persistence layer. So this couples our domain logic to the database, or at least to the database, to the persistence layer before the database. And usually we're starting in a setup like this. When we're developing a certain use case, we're starting at the bottom layer. We're starting by creating an entity, creating a repository, creating the database table, the database structure, and only then we're going to the domain layer and build our application logic. When it should be the other way around. We should build the business logic first and then care about the database and persistence layer, because the business logic is the more important code. The next thing about layered architecture is that we're usually having this service layer, this domain layer, and if we have certain classes that are used throughout multiple layers, we just push them to the bottommost layer because everyone can access them. So we have utility classes and perhaps other classes that are needed everywhere, that should be accessed everywhere. We just push them down to the lowermost layer, so every other layer above it can use it. This makes the boundaries we have, they're easily blurred. If you don't have the discipline, or if you don't have something in place that catches it. So there's no real boundary if you don't especially build it into your architecture. Next thing is layered architecture allows shortcuts, like layer bridging, where we're accessing the persistence layer from our web layer, for example, which is not bad per se, but if we do this, then the tests are going to be a little harder, at least if we were doing unit tests. So for the test in our controller here, we would have to mock the business layer away, and we would especially have to mock away repositories, so we're having a lot of mocks. If someone new comes to the team and sees the test code, he might get confused. Tests are getting harder. We have to mock more. We have to mock different layers, different technologies. It's going to be a little harder than if we just have to mock away only one layer. Next important thing I have observed in a lot of projects is that the functionality we're building, the use cases we're building in our application, are actually hidden somewhere. We have a service, which is a business service or domain service or whatever, and it's doing a lot of different use cases. So, for example, we have a service that is concerned about orders. So to create an order, to update an order, to, I don't know, place an order, whatever. This service does everything for orders and everything that's around the entity, around the order entity. And you don't really, if you're looking for a certain use case in the code base, you know that it's somewhere in this order service, but you don't have, you have to search through this service to actually find it. So this is, makes use cases, usually makes use cases hard to find if we have these broad services that are spanned across multiple use cases. And it also makes it hard to work in parallel on the same feature. So if two developers are are working on the same or a similar feature, they both have to work in this service and might have merge conflicts and other problems. So, what's the cure? Instead of layers, we just do circles. So, we just wrap the layers around each other, and everything gets better. I'm not done yet. There's something coming at me. Okay, so this is what Uncle Bob, Robert Martin, calls clean architecture. I'm going into a little more detail later, but first let's look at solid solid principles. Everyone knows them, right? You can, if you're getting woken up in the middle of the night, you can say what SOLID is, right? Who can do that? Oh, come on. I know you can. Okay, I'm not going to ask you now, I'm just going to open this up. So, single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, dependency inversion principle. We're only going to look at two here, which I think are the most important ones, and which motivate the architecture style that I'm going to introduce. So let's look first at the dependency inversion principle. What does that mean? Obviously, it means that we can invert dependencies in some way. It means that this is our, on the left side is our database-driven design. Now we have the service, we have the entity and repository, and the service has a dependency on the persistence layer. So we're bound, we're coupled to the database through the entity. If we apply the dependency inversion principle, we turn this dependency around so that no longer the domain layer no longer has a dependency to the persistence layer, but the other way around. This is on the right side. We see we have, I also replaced service with use case here, but that doesn't matter. It means on the right side we're using dependency inversion, which means we have moved the entity up into the domain layer so that our domain entity, this is actually now a domain entity, no longer a JPA or Hibernate or whatever entity. And in the domain layer, we added an interface, which I called repository here, but which doesn't necessarily have to be named like that. And the persistence layer simply implements this repository interface with whatever technology is sensible in the project. JPA, Spring Data, JDBC, whatever. So what this means is we can choose the direction of any code dependency as long as we have control over the code. If we have a dependency to some third-party framework, third-party library, obviously we cannot change the dependency because we can't change the code. So what does that mean on an architecture level? And this is where the clean architecture ID comes into play. Clean architecture as a buzzword is not that young. It's been around, I don't know, for how long? 10 years or so, I'm not really sure. But Robert Martin has recently published a book, Clean Architecture, about this, which explains this architecture style. But it's very generic, but I'm going to, this is the only slide about it actually. So I'm going to not go into the details here, but go over the main facts. So what have we here? We have in the middle our domain layer, and there are layers around that, and the main rule is that dependencies only may point inwards. So, for example, the blue circle, we have the UI code, the code for the UI, or the code for accessing the database. It may access the green layer, and the green layer may access the red layer, something like that. We have applied the dependency inversion principle to actually allow this change of dependency. Yes, and this is actually it. We have the domain logic actually in the core, and everything on the outside is just a detail. So if you believe Uncle Bob, the database and the web are actually only details to our application. The important stuff is the red stuff in the middle. I see that a little more pragmatic. I think it's pretty important that we have a web layer and then we have a database layer, because otherwise the data just gets lost. But what it means is that we can actually change the database later on and exchange it by, I don't know, storing files on a hard drive or something like that. So this is dependency inversion. We inverted the dependencies. Our domain layer is no longer dependent on a persistence layer because we turned the dependency around by introducing an interface and implementing this from the outside. The next solid principle I want to talk about is single responsibility. The single responsibility principle, who knows what it means? Yeah, just, I can't see you anyway, just tell me. What does it mean, single responsibility?
One reason to change a class.
You're cheating. Yes, I was expecting something like a class or module should do only one thing, but what you said is completely right. A class or module should actually only have one reason to change. So this is a common misinterpretation of the single responsibility principle, that it only should do one thing, while actually it should only have one reason to change. It's a slight difference, and it's not so big a difference, but a meaningful difference, because if a certain module or class does one thing, but it has multiple reasons to change, because there are different requirements that produce a change in this module or class, then it's going to change all the time. While if a certain module or class only has one reason to change, it's only going to be changed for this one reason. And this makes the code base just more stable. So, and instead of module, I put the word module here. Instead of module, you can read class, package, component, whatever element, architecture, or code element you want. So what does single responsibility mean on a macro level, on an architecture level? If we look at the layered architecture, our business layer or our domain layer has one reason to change that it shouldn't have, and that's the persistence layer below. If we change something in the persistence layer, in the blue layer, in the bottommost layer, there is a certain possibility that we have to change things in the business layer too, because the dependency points downwards. So changes in persistence may affect business code, which we don't really want. In this clean architecture, circular style, when we applied the dependency inversion principle, this is no longer the case, because the dependencies point towards our business layer, and if something on the outer layers changes, the business layer doesn't have to change. So this makes the business code more stable. This means single reason to change, single responsibility on a high level, on a macro, on an architecture level. And this means we're free to do everything we see fit, everything that we think is good in our domain layer. We can do everything without even having to think about persistence effects, persistence problems, lazy loading, stuff like that. And I go so far and say that only a domain-centric architecture, which has the domain layer in the middle of it, and dependencies pointing toward the domain layer, allows domain-driven design. Because only then we can design, we can design freely without having to think about certain technology issues. Only go so far, but the gist is that this is true. What does it mean on a micro level, on a class level? Single responsibility. In our layer architecture, we often have the case that we have these broad services I talked about earlier, and we have multiple actors using this service. So for example, if this is an order service, providing use cases around orders, placing orders, whatever, and we have three different user roles that actually use this service, use cases in the service. We have 3 actors that use the service. So if one of these actors, if one of these user roles requires a change to the application, we have to change this service, and we have to test everything else that's in it again, even if the other 2 actors are not actually, don't think that anything has changed. So what can we do here? We can split our service up into use cases, actual classes that are named XYZ use case, and each service or use case, or whatever you call it, is responsible for 1 actor, for 1 user role. And if you take this to the extreme, every of these classes are actually only responsible for 1 use case. So, and this brings me to the next architecture style, which is hexagons. So we're talking about a lot of shapes today. I think a hexagon is more sexy than a circle because it has these edges, but that's just personal meaning. What does it mean? If we drill into a hexagonal architecture, this is my interpretation of a hexagonal architecture. It looks like this. We have a hexagon, obviously, 6 sides, 6 corners. And within the hexagon, we have our domain layer, our domain code, use cases, entities. On the edge of our hexagon, of our application core, we have ports. On the left side, we have input ports. And on the right side, we have output ports. Input meaning we provide an interface, we provide an API to outward, let's call them adapters, to outward code that wants to call our application logic. And on the right side, the output ports provides functionality for example, persistence. We call our application core calls something else. So why is this a hexagon? I don't really know. And I don't think Mr. Cockburn, who branded the word hexagonal architecture, I think I read somewhere that he meant just it's because boxes with 4 corners are boring, and he wanted to show that an architecture can actually have more than 4 sides. I don't really know what he meant, but if you think that 6 sides are too much for you, you can just choose any polygon you want. For example, if the customer says that, oh, six sides are too much for me, you can just go with a triangular architecture. But then you should be prepared that the customer only wants to pay half for it because it only has half the number of sides. So be careful with that. So actually, the hexagon doesn't really mean anything, but it looks cool, so we'll stick with the hexagon. Back to use cases. I mentioned before that use cases should be, that services should be cut into multiple use cases so that each use case only has a single actor. So use cases, we should treat use cases as first-class citizens in our architecture. And in a hexagonal architecture, this is just much more concrete than in the clean architecture I introduced earlier. If you Google the words clean architecture and hexagonal architecture, you find very much about the high-level concepts. But at least if you're looking for clean architecture, if you're looking for hexagonal architecture, you even get some code examples, because clean architecture, it's just a concept, and hexagonal architecture is an instance of clean architecture, which actually puts the concepts which is easier to turn into actual code. So what does a use case do? A use case class implements an input port The input port is just a Java interface. Then the use case class modifies the domain model, the domain entities in some way. And on the way, it might call certain output ports, for example, to load data from the database, or to send data to the database, or to load data from some other external system, whatever. Let's have a look at the impact of this style, of this architecture style with having specific use case classes. So this is a package structure of a little application without actual use cases. Can anyone tell what this application does? Pardon? It records time, yes. Very smart. Anybody, any other guess? Well, it obviously does something with time, so you're completely right. You can't tell any more than it records time, so no offense to you. I couldn't have seen it anyway, either. It does something, we have a service, it does something with time records, but what's a time record? I don't know. What do we do with these time records? I don't know. If we split it up in use cases instead, we get this. Can anyone tell now what this application does? Pardon? Yes, manages time records. We can even probably go one level deeper. We see that we have multiple use cases. We can submit time records, we can approve time records, we can reject time records, so it's actually probably multiple users, multiple roles. We have approving use case, which is done by probably another role, so it's probably a time tracking application where you track your time and later on you create invoices from that track time. You can do this in a layered architecture too, so this is certainly a good way to go, but in this hexagonal architecture, this is even more powerful because of the dependency inversion, and we don't have to change use cases because persistence code changes. Okay, let's look at some code. I promised to show some code. You can find the code examples at this link or in the slides. Can you see it? Okay. So what does code look like? So this is just a disclaimer. This is my interpretation. There are certain, we can certainly do it in different style. This is just one template one could use to create such a hexagonal architecture. With or without Spring. I'm going to point out the Spring parts on the way. So this is we're going to implement a use case that is called register book use case. So the application is about, it's a book reviewing application. So if you write a book, you can upload the book in Markdown or whatever other format, and you can provide it to other people who can then review the book and edit and suggest edits and stuff like that. So the first use case in this application is to register a book. So I'm an author of a book, and I want to register my book there. It actually is a simple create use case. We just create a book. But I don't call it create book because that's too generic. I call it register book. So we should try to call our use cases with the most, with the best verb possible. And create is just too generic. So we have this register book use case, which is an interface. This is our input port in the hexagonal architecture. It has a single method currently, which is register book, which takes a register book command, which contains all the data that is needed to execute this use case. The register book command, I put it here into this interface as well. It just has two fields and a constructor that takes these fields as input. Here's the first question about validation. I chose to validate the input on this level, so the register book command actually implements or extends a self-validating class which simply creates a Java Bean validation validator and calls the validations, so it resolves these, it evaluates these Bean validation annotations. So we can only create a command object that is valid in the sense that the business logic expects. So the business logic itself can then work with these attributes and doesn't have to do the validation itself. There's also an exception here, which I don't know if it's a good idea, non-unique book title exception. Perhaps a better way would be to not use this, to not create an exception in this case, but instead, before calling the register book method, to actually check if there is already a book. But that's just a little flavor. So we have this register book use case, no Spring so far, even though there is here a Spring icon. So what does actually implement this interface? I called it register book service, so it's a service which serves only this actual one use case. And it implements this method. And so when we're starting to implement this register book method, we just type away and implement our business logic, and we find that we need an author entity. So we just create an output port, which I called find author by ID port, which only has this one method, find author by ID. And we're happily coding some more. Then we find, okay, we need to persist this book somehow, so we create another output port which takes the book and persists it in the database. Still very little Spring here, but we're using Spring's @service annotation to declare this service as a Spring Bean. One thing you could do here is, if you want to make the architecture even more evident in the code, you can create your own annotation and annotate this, meta-annotate this annotation with the @component annotation, and then you actually know when you look at this that this is a use case. Spring serves as a dependency injection mechanism here to fill these fields. I'm using Lombok here, which automatically creates a constructor for all required, for all final attributes, and Spring automatically injects implementations of these ports. So if we have created a test before, and we run the test now, and without having implemented these ports, the Spring container won't fire up, and it will tell us there is a port missing, which is pretty cool, because Spring checks our architecture for us. Okay, so this is the business logic, very little Spring here. The only thing Spring does is actually dependency injection. That's the way it should be. So Spring is very non-invasive. Spring is in the behind the scenes and does the work behind the scenes, and we don't have to actually use any Spring code except for perhaps one or two annotations. So this is our business code. I didn't actually explain the package structure, so we have an application package structure with a port package, input ports, output ports, so these are just the interfaces, and we have a service package within the application package which has our register book service. So now we somehow have to implement these ports, and these ports are implemented by our persistence adapter. So hexagonal architecture, we have the core in the middle, and on the outer layers we have adapters that call our core or that are called by us. And here I took, again, I created a custom annotation, which you don't have to. You can also use this one. but it just makes it more evident. And this implements some output ports. It's in its own package, and every class in this package actually is package private. We don't need to publish it out to the outside of this package, because Spring allows to inject beans into the Spring context without them actually being public, which is pretty cool, because we can't accidentally call persistence code from our business layer then. And this is pretty simple code. It takes a book and saves it. This is a Spring Data JDBC repository. Pretty simple stuff. Yeah, one thing about this book class. The book class is in our domain package. So this is actually in the middle of our hexagonal architecture. Oh, don't forget to track your time. Sure, I will. I chose here to add this ID annotation. This is an annotation of Spring Data JDBC, or actually, I think it's not even JDBC, it's just Spring Data in general. So I chose to use the same object in my persistence layer as I use in my business layer. But the persistence layer needs this ID annotation, so now I chose to just put it here. This is kind of a shortcut because, again, in my business code, I actually don't want to have any persistence, any dependency to persistence code. But I think if you're starting to build a use case, many use cases start as a simple CRUD use case. We create some entity or something like that. We can start with this. So we can add some JPA or Spring Data annotations to the entity in the business layer, and then we can just pass this entity along to the persistence layer, who then persists it in whatever database. However, once we get to a point where the use case evolves to something more complex, and we start, we're thinking about, oh, we're doing some persistence relevant code here in the business layer, we can then choose to remove this annotation from our domain objects, and then just introduce a mapping here. So here we would map the book to some JPA entity, or we just move it to the database via plain JDBC. So that's what I want to bring across. We don't actually have to start with these very strict boundaries between the layers. We can start without these mapping steps, because that's one of the main criticisms about hexagonal architecture or clean architecture in general, that we have to, in each layer we have our own model, and we have to map between these models, but we don't necessarily have to do it this way. We should start to do it this way if we think we're doing code if we're putting code in the business layer that has to do with persistence and stuff like that. So there's also a web adapter in the adapter package, which is simply a REST controller, which is, I'm not going to details there because it's pretty straightforward. Okay, so we've seen this. So to sum up what Spring does for us in our architecture, Spring doesn't really care about the architecture we're implementing, which is a good thing. Spring is always in the background, has been in the background since day one, I guess. So if we think about architecture, Spring doesn't care. We can build any architecture with Spring. So we have a lot of options of doing things. Spring also helps to test isolated parts of our architecture. We've seen in the talk before about the component scanning and stuff like that. But we can also do specific Java configuration files that only spin up part of our application so that we can test this part of our application in isolation. Oliver Drootboom has given a talk yesterday about monoliths. This is one option we can also do here. And to sum up, Spring is easily held at arm's length. So we don't really have to buy into using Spring because Spring is in the background. Okay, I'm going to skip the mapping strategies because I've just told you about it, that we can use different mapping strategies. We can do no mapping, so the ports, the output ports, and the persistence adapter use the same entity as the domain layer, or we can do something like this in the front in the interface to the web adapter using a command pattern, which is a more elaborate mapping strategy. How can we enforce architecture? Just really quick, we can build multiple jar files, separate build artifacts, so that the dependencies are resolved automatically by Maven or Gradle or whatever. We can use something like ArcUnit, which is a framework that allows to enforce certain package structures, or even more than package structures, actually. I'm only using it here to enforce package structures, package dependencies, actually. Or we can use the monoliths approach by Olli, which he introduced yesterday. I just added this slide after the talk. We can use Java modules, which will probably work too, but I'm used to having a little more time to learn new Java stuff, so I haven't looked at it yet. Yeah, that's about enforcing the architecture, which is important. Enforcing the architecture is kind of important, because if you're not doing microservices, yes, I said microservices for the first time in this talk, which is great. If you're not doing microservices, if you're building the application in a giant, in a monolithic code base, then it's very important to enforce architectural rules, because otherwise certain design flaws will slip in. Okay, to conclude, what are the benefits of a domain-centric architecture like clean architecture or hexagonal architecture? We have separate classes for separate reasons of change, so we don't have this coupling to the database. We can find our use cases better because we separate them in different classes. We can work in parallel better because we have cut things up into more smaller pieces. It's easier to test because the dependencies are clear and the boundaries are no longer blurred so easily. There are certain drawbacks, certainly. Just as I said, there is, if you make hard boundaries, building boundaries is expensive. Just ask Donald Trump. I think he has a problem with the boundary currently. So we have, each boundary requires, if you want to do hard boundaries, you have to do a mapping. And so it might feel that you have to map a lot. We have some perceived redundancy, because if we cut the use cases, if we make the use cases separate from each other, we have to duplicate some things. So if we change one use case, the other one won't have to change. And we need real business logic. It's very hard. If you just do a simple CRUD application, you don't need this architecture style. So this only really helps if you have real business logic that you can put into the middle of into the center of your architecture. Then you have the real value. And that's it. Thanks for your patience. I've summarized some of this and a little more in a little ebook, which you can download under this link. Thank you for your patience. It has been a lot of fun for me.